welcome back to my channel, the channel for sharing the knowledge and experience. At this moment, I would like to share my experience with the air particle counter qualification process. As you know that this device is commonly used in cleanroom qualification. It will counting the airborne particle and also it will show us what is the level of the class of the cleanroom. Before we conduct the qualification of the room, we need to conduct also the qualification for the device, for the air particle. We need to make sure that device is working well, so we need to qualify it. But now, the question is, how we qualify the particle counter? Commonly, people just transfer this device, these qualifications, to the vendors or to third party. But I think it will take a lot of cost of money, so it's better for us to understand how to qualify this device. In this video, I will show you the hardware. I will show you the part of the device, so you can understand, you can identify what is the critical parameter and what is the quality attribute that you should verify in the qualification. You can make the protocol for installation qualification or operational qualification or the performance qualification. So just make sure to watch this video completely, and I hope you all enjoy this and get much benefit from this. But first, for all of you who just first time watching my channel, please subscribe and click the bell for the real-time notification. See you in the comments and see you in the next content of my channel. Thank
you. The remote air particle counting which applied light scattering theory will mainly consist of four main parts. These main parts are schematically role its functions. First is ice kinetic probe. Second is particle counter control box. Third is power panel box. And the last is a HMI, it can be touchscreen or PC. Now, let us break down this part one by one. Ice kinetic probe. This probe is an inlet air that consists of suspended particle to be measured. Since this probe will be placed in the cleanroom, so the material used should derive from an inert material, such as stainless steel sanitary grade. The diameter of the probe should also width enough to take the air in certain flow rate. Ice kinetic probe should be placed a little bit under the working area since it will take the air in above the probes. Next, the particle counter control box. This unit is the critical and central unit. In this box, the light scatter theory is applied. Amount of particle is measured and counted by a processor after receiving data from photodetector. The processor is receiving command from HMI and do the process as commanded. The measurement result will be transferred back to the HMI afterward. So, in this box there are critical part to be verified before conducting the qualifications. In this video, we will try to open the box and show you what is the critical parts and its function as well.
Now, let's start to identify the CPP and CQA. CPP should be identified and defined properly in order to have the definition of qualified condition. And CQA need to be defined to ensure that qualified status is achieved and the conclusion will be trustee concluded. How to identify the CPP? Please consider the following analysis. 1. Answer the question of what is the critical factors of the air particle counter system that hold an important function so that if these important things are not working will make the counters malfunctioned. 2. If these critical functions are not identified, the variable of the system will make the measurement not reliable and having so much variation. After knowing the mechanism of the counter, we can have a summary of the critical process. First is the air intake. The air should be taken in by a vacuum system in a certain rate. Thus, the performance of the vacuum pump should be ensured. Second is laser beam shooting with the suspended particles as target. Laser beam should have a certain intensity and wavelength which can be read by the detector. Third is scattered light detection. Scattered light as a reflected light after collided with the particle should be able to detect by the light detector. Light detector should be ensured working properly. Fourth is data processing. The detector will send the impulse to the processor. Processor should have a power supply to start the data processing. Fifth is data acquisition. The processed data should be sent by processor to the HMI. Connection or communication between these two units should be ensured running well. Now we can summarize. 1. As a critical process, air intake should be verified by measuring the flow rate. Calibration of flow rate meter should be conducted. Vacuum pump motor drive also should be ensured that the pump is working well. And ampere measurement could be an option to verify. 2. Laser beam intensity and wavelength should be verified by intensity meter or its relevant certificates that indicate the intensity level and wavelength. The self-life or lifetime certificate of the laser beam generator also could a consideration on verifying the performance. For the detector, verification of performance could be verified by the calibration certificate or challenge test. Third, data processor could be verified by checking the power supply connection or the frequency of the processor. Fourth, to verify the data acquisition, connection or communication between processor and the HMI should be ensured. Check the communication port and converter. If the communication using IP MAC address, please check the IP address. If the converter for Profibus is needed, check the converter. Fifth, data record is another function of air particle counter. This data record should have an integrity before exposing the data as the result of measurement. Please check the data access, data storage and capacity, data presentation in electronic and physical data, data security system. Next. After we ensure the CPP, now we will define and verify the CQA. The air particle counter will able to conclude as a qualified particle counter if it able to measure and count the particle, able to show the airflow rate information, able to maintain the setup parameter, able to secure data, and able to alarm if any inappropriate condition happened. So that the quality attributes to be verified will be particle counting, flow rate measurement, process parameter setup, data storage, and alarm notification. How to verify depends on the validation engineer technique. Most of people are having difficulties in developing the protocols. They will just take the manuals, and facing the PC or laptop while expecting their hand start to type the protocols or procedures, but in time, their hand not even start to type. So, knowing the CPP and CQA will be very helpful to start developing the protocols. You will understand the 5 watts and 1 H in air particle counter qualification process. The CPP and CQA is not limited to what we have discussed earlier. You can elaborate with your own technique and your counter complexity. The CPP and CQA analysis is also a part of risk management in developing the qualification protocols. Hope you all can do the qualification better.